Hello there, welcome back to another video. Again, we're looking at quadratic sequences, and I just wanted to do a few more examples just to make the idea really clear and just so everyone understands what you need to do should you get questions. So in this video I'm going to have 3 questions starting off easy, medium and then hard. So let's get straight into it. Hopefully you've seen my last video where I showed how to derive the formulas. Right, our first question, the nth term of a sequence is 2n squared plus 4n minus 1. Work out the 10th term of the sequence. Now, this should be screaming out to you, just put n equals 10. And we will get 2 times 10 squared plus 4 times 10 minus 1. Right, and this equals, well, 10 squared is 100 plus 40 minus 1. Which equals 239. Okay, question 2, and this time we are going to need the formulas, so I'll quickly write them down. The first one says that the second difference, and I'll explain what we mean by the second difference in a moment, is equal to 2a. So I'll just say we're trying to find an expression of the form an squared plus bn plus c, where a, b and c are constants. Our second formula says that the first term, in this case 2, equals a plus b plus c. And finally, our third formula says that the second term, take away the first term, equals 3a plus b. Great. Okay, so here's our sequence. Now let's work out the first difference. So that's the differences between these terms. So 2 and 10 is 8, 10 and 24 is 14, 24 and 44 is 20, and 70 and 44 is 26. Now we're looking for the second difference because it's quadratic, so second order. 8 and 14 is 6, 14 and 20 is 6, 20 and 26 is 6. So let's look at formula number 1, that's this one. The second difference, which is this number, 6, is 2 times a. So if 2 times a is 6, then this tells us that a equals 3. Right, so we've got a equals 3. Now to find b, we substitute our a equals 3 into this thing here. So 3 lots of 3 plus b, and this is equal to the second term, take away the first term, which is 8 here. So 9 plus b equals 8, this tells us that b is minus 1. So hopefully you can see that. Okay, to find c, we need to plug our a and b, which we found, into here. And a plus b plus c, this is the first term, which is 2. So a plus b plus c equals 2, implies 3 plus minus 1 plus c equals 2, and this tells us that c equals 0. Okay, great, so we've got a equals 3, b equals minus 1, and c equals 0. So our nth term is 3n squared minus n, and that is the answer there. Right, good. So here's our last question, and this is about as hard as it gets, I think. So it's a two-parter, a and b. First, show the nth term is 2n squared plus 4n minus 14, and this is quite nice because we know that if we get that as our answer, it's correct. But the second part, hence determine whether 272 is a term in the sequence. So again, we're just going to make use of our rules. So let's write the sequence down again. So it's minus 8, 2, 16, 34, 56. Let's calculate the differences. Minus 8 to 2 is 10. 2 to 16 is 14. 16 to 34 is 18. And 34 to 56 is 22. Okay, let's calculate the second differences. 10 to 14 is 4. 14 to 18 is also 4. 18 to 22 is also 4. Hope you can see that there. Right, so again, this tells us that 2a equals 4, and so a equals 2. Excellent. So already this agrees with our coefficient of n squared, so that's good. Okay, our second formula is 3a plus b. So this is 3 lots of 2 plus b, and this is equal to the second term take away the first term. So it's this number here, 10. So 6 plus b equals 10. This tells us that b equals 4. And again, we look up to the question, does this agree? Yes. And finally then, let's work out c. So a plus b plus c equals the first term, minus 8. But we know that a is 2 and b is 4. So we got 2 plus 4 plus c equals minus 8. This does indeed tell us that c equals minus 14. Excellent. So just to finish this off, we'd say the nth term is 2n squared plus 4n minus 14. Great. Right, part B. Part B says, is 272 a term in the sequence? So what we need to do here is we need to say, well, will our nth term ever equal 272? So 2n squared plus 4n minus 14 equals 272. And we'll put in a bit of a question mark because this is the question we're trying to answer. Right, you might spot that we can divide everything by 2. So this gives us n squared plus 2n minus 7 equals 136. Okay, now we can bring this over to the other side and we will get n squared plus 2n minus 143 equals 0. Great, so now we're in the old familiar territory of solving quadratics. So this is a quadratic equation. So you could do this using the quadratic formula. You could factorize. You could complete the square if you wanted. But hopefully you should be able to see that 143 equals 11 times 13. Yeah, it's another 13 onto 130. So we can factorize n plus 13 n minus 11 equals 0. So this tells us that n equals minus 13 and n equals 11. Now the alarm bell should be ringing with this answer. Can n be negative? No. N can't be negative because the number n denotes what term we're at in the sequence, and you can't have a negative term. Therefore n equals 11. i.e. 272 is the 11th term. Right, and if you really wanted to be rigorous and check this, you could substitute n equals 11 into our nth term. So I'll go ahead and do that. So if you remember, our formula was 2n squared plus 4n minus 14. So when n equals 11, we get 2 lots of 11 squared plus 4 lots of 11 minus 14. So this equals 2 times 121 plus 44 minus 14. 2 times 121, well that's 242. 44 minus 14 is 30. And we do indeed get 272. So if you wanted to finish this off, you'd say, yes, 272 is in the sequence. And we're done. So I hope you enjoyed this video, guys. Leave a like if you did, subscribe for more. Bye bye.